baggage tractor pulling luggage carts. Hot potatoes. How excited am I? Okay. What's going on here? The tractor has a mass, and then the mass, cart A has a mass and cart B. I'm just going to label these real quick. So this one is 650, and then cart A is 250, and this is 150. And the driving force accelerates it from rest and X for 30 seconds, and the driving force is given by this. Ooh. Okay, find the speed after 3 seconds. Okay, so let's do the whole system as a big chonkadoodle. So we have big chonkadoodle, and the whole thing together, chonkadoodle, weighs 650, or has a mass of 650, 250, and 150. So chonkadoodle of 1050. So giant box of 1050. And for some reason, they're driving it to the left, but I don't like driving left. I'm going to drive right because right is positive and I think better that way. So I'm going to ignore their stupid picture and I'm going to go this way. And I know that it's going. Are y'all okay with me doing? Well, it's fine. Video's free, deal. So there's some kind of a force equals 820t. Awesome. With respect to time. All right, find the speed. Well, you know, I know that the sum of the forces. Oh, I didn't finish drawing my free body diagram. I am so crazy. Okay, so the weight is 1050 times 9.81, and the normal force is the normal total force. I don't really need it. I'm just labeling it, so I have it. Okay, now I can do the sum of the forces in the x direction is 820t, and that's the mass times the acceleration in the x direction. Okay, I'm just going to hope that the math works out. Okay, the mass was 1050, and I don't know the acceleration. It just didn't tell me. Nope, it just said that it acted for 3 seconds. Okay, this is where you have to know things. All right, so first of all, let's see if I can make these numbers prettier. Does 820 and, hold on, 1050 divided by 820 look pretty? 105 over 82, that's it? Okay, well, I think I could have figured that out. So I'll make those go away. So I'll have 82t equals 105 acceleration in the x. But instead of writing a sub x, remember that acceleration is dv dt. Okay. Now I'm going to move my dt to the other side, so all the t's are on the same side of the equation. And now I'm going to integrate. Does it start from rest? I'm pretty sure they said it did. Starting from rest and x for 3 seconds. So it starts from rest, goes to some unknown velocity, starts from time equals 0 and x for 3 seconds. So I've got, what is 82 divided by 2? 41, I hope. But you know, sometimes I do stupid things. You may or may not be aware. Yeah, that's clearly 41. So I have 41 t squared evaluated from 3 to 0, and then 105 v evaluated from v to 0. I don't know what t squared is. How am I supposed to know what t squared is? I mean, I know it's 9, but 41, no, yes, times 9 equals 105v. So v equals 41 times 9 divided by, that doesn't look like a times, 105. Let's see what happens. I'm also going to come back and look at my units here in a second because things seem like they could get scrunchy. 3.51. Okay, let's make sure these units make sense. So I have 50 what was that units there? What were this even given to me as? Newtons. Oh, it's going to be weird because they labeled it funny. Meters per, it's just going to have to be meters per second because I think they labeled something weird in a way that I didn't like. It's just meters per second. We're just going to have to deal. You're going to have to be okay with it. So velocity is 3.51 meters per second. But you see how I didn't have to like go look up a specific equation. I had to use the knowledge that I already have to do stuff. Does that make sense? I'd use the knowledge that I already had to go through and create, I could just derive it. I didn't have to go look up a specific equation and memorize something. I could just be like, oh, I know how to solve this problem because I understand the physics and the derivations of where all this comes from. So 3.51, was that the answer? Yeah, okay, awesome. And then there's another question. What is the horizontal force between the cable and cart A? Okay, so if I'm looking at the tractor and cart A, so now I've got tractor, and this is now just regular tractor, and he is 650. And he's got a weight of 650 times 9.81, and just the tractor itself has a normal force now. So he still has that F of 820T, but now he has a towing force for A. He's pulling A. So A is pulling on him. So if I drew A would look like this. And then B would look like this. Whatever this mass are. Okay, so you see those TBs and those TAs, they cancel each other out when we put the system together. So when we break them apart, we expose those previously internal forces as external forces, so now we can see them. Okay, so if we're doing this and we want to know what that internal force is, we have to expose it. So the sum of the forces in the x direction is 820T minus TA equals mass times acceleration in the x direction. Okay, so we actually need to figure out what that was. What is that? So there was probably a way I could have figured this out from here. Oh yeah, okay. So if acceleration 105 acceleration x equals 82t, then ax equals 82 over 105t. And at t equals 3, that means my acceleration, whoa. Come here, girl. Okay, come on, I know, we're almost done, baby. Okay, now I've just upset everybody. There we go. 82, whoa, times 3 divided by 105, ponk, 2.34. Now notice that that is only accurate at t equals 3 seconds. That's why I can't just find like A and then use my acceleration as constant formulas, and I think I kind of glazed over that, but I have to do integration because acceleration isn't constant because the force isn't constant. So I can't use the 1/2 at squared thingy. Okay, so remember that 1/2 at squared thing only works whenever acceleration is constant, which only works when forces are constant with respect to time. Okay, but since this is not constant with respect to time, I have to go do integration, which is why this is calculus-based physics and not snuggle-based physics. Okay, but I can say at, whoa, that's not right, at t equals 3, this becomes 820 times 3 minus TA equals mass times 2.34. And the mass of this dude was what, 650? I've already forgotten again. Yeah, 650. Okay. So this equation is only good at t equals 3 seconds. So that's really important. So I've got 650 times that 2.34 minus 820 times 3. It's going to be a negative. Oops, did I do this in the right direction? Maybe. I feel like I have, oh, because I missed a 2. Yeah, that'll make a big difference. Okay, so I have negative TA equals 937. So TA equals 937. So at that exact moment in time, the tension between the two cars is 937 newtons. So that means that if you're designing this cart thing, that your trailer hitch thingy needs to be able to maintain that level of intensity and strength.